Algebra 2, Chapter 3, Section 3, Absolute Value Equations and Inequalities. What's absolute value? Absolute value we can think of as the distance of a number from 0 on the number line. So if we think of a number line, and we want to know what is the absolute value of 3. The distance from 0 to 3 is 3. So the absolute value of 3 is 3. We write absolute value with 2 bars in algebra. What about negative 3? The distance from negative 3 to 0 is also 3. So the absolute value of negative 3 is 3. In other words, the absolute value is basically the number without the sign. And we can define this formally, algebraically, as the absolute value, these 2 bars, means the absolute value of x, is either going to be x when x is positive or 0, or negative x when x is negative. Negating the negative makes it positive. Since absolute value has to do with distance, the absolute value of the difference of 2 numbers gives the distance on the number line between the 2 numbers, a and b. So, for instance, the absolute value of 7 minus 1 is 6. That's the distance from 7 to 1. And we'll do some more examples here to show us how to make use of this information. For many of these simple absolute value equations and inequalities, we can use 2 methods. We can use a geometric method to solve, or we can use an algebraic method to solve. And I think the geometric method is faster for simple problems, and the algebraic method is faster for more complicated ones. But let's work this one both ways. The geometric method says, okay, we know the difference between this unknown number and 2 means the distance from the unknown number and 2 must be 4. So if we think about a number line geometrically, the distance between 2 and this unknown number, x, must be 4. Sorry, the distance x is this number on the number line. Or x is this number when we take 4 away. Either way, moving 4 from 2 will give us x. And geometrically, we know then what x it must be. It's either 6, 2 plus 4, or negative 2, 2 minus 4. So x is going to either be negative 2 or x will be 6. And in my class, I don't mind if you just write a comma to mean all this stuff, or x. This to me means x is either of those 2 things. To do this algebraically, we remember the definition of absolute value. From the definition, we can write 2 possibilities. Either x minus 2 will equal 4, or either x minus 2 will equal minus 4. So there's 2 possibilities. Really, actually, it's not minus 4. It's either x minus 2 is 4 or negative x minus 2 is 4. Those are the 2 possible choices. So multiplying by the negative will give us 4. And this will become important with inequalities. So here we have x is 6, or we multiply by negative 1, and then adding to 2, x is minus 2. And we have the same answer. Now let's solve a different one. X plus 6 is 15. Well, remember the geometric one had a minus, but we can turn a plus into a minus a negative. So if we think about it geometrically, what numbers are 15 distance away from negative 6 Well, that would be negative 6 minus 15, which is minus 21, and negative 6 plus 15, which is 9. So in this case, x will either be minus 21 or 9. Let's solve this one algebraically. So we have x minus 2 is minus 3. So algebraically, there's two possibilities. Either x minus 2 is minus 3, or negative x minus 2 is minus 3. So we get x equals minus x, so we add 2 to both sides, we get minus 1. And here we have x minus 2 equals 3, adding 2, we get 5. But let's be extra careful here. Let's try putting these values back in and seeing if we get a true value. Minus 1 minus 2 equals minus 3. That's true, but let's think about the absolute value. That'll be the absolute value of minus 3, but the absolute value of minus 3 is just 3. We dropped the sign. So here we see this is not true. So this idea of splitting it into two possibilities actually yields potentially some extraneous solutions. So we should check. And if we think about this before we did anything, if we thought about it geometrically, we'd be asking, when is the distance between an unknown number and 2 negative 3? Well, distance is never negative. So the answer is no such x. These are extraneous solutions. If we put 5 back in, we also get a positive equals a negative. Here we have 3 times some unknown number, and the distance between that and 4 is 11. So solving this geometrically gets kind of challenging unless we do a substitution. So instead of solving this one geometrically, let's do it algebraically. So let's write 3t minus 4 is 11, or 3t minus 4 is minus 11. So 3t equals 4, t is 4/3, or 3t equals minus 11 plus 4, which is minus 7, minus 7/3. So t is either minus 7/3 or 4/3. So you can see why we did this one algebraically. It's faster than trying to think about it using the distance. Now, I went too fast here and made a mistake again. Hopefully you caught it as I was going. We have minus 4 here, and I added 11 to 4 and got 4. That's not correct. It should be 15. 15 divided by 3 is 5. So it always does help to check your work. Plug it back in and make sure that you get a true value. If you don't, there's a mistake. So let's move on to an inequality. Let's first do a simple one. Let's solve the absolute value of x is bigger than 5. We can think about this geometrically. Could think about it algebraically too, but this one isn't too hard to do geometrically. So we're saying the distance from an unknown number and 0 on the number line is bigger than 5. So the distance from the unknown number and 0, so x is the unknown number, has to be bigger than 5. So x then has to be either bigger than 5, or it has to be smaller than negative 5. In order for us to get a true value in this inequality. If I put in minus 6, I get the absolute value of minus 6 is 6, which is bigger than 5. So the answer is x has to either be smaller than negative 5, or x has to be bigger than 5. So here's a harder one. Absolute value of 2x minus 3 is less than 7. So instead of thinking about this one geometrically, let's do this one algebraically. Let's write two possibilities. So either 2x minus 3, either that is less than 7, or the negative case, the negative of 2x minus 3 has to be less than 7. So 2x minus 3 less than 7. And I wrote it this way with the negative because I need to multiply by the negative 1 and flip the inequality. This is critical to doing absolute value inequalities. Just like we talked about before in 3.2 with multiplying by a negative, it comes up again here. So now we add 3 on the left inequality and we get 10, as long as we do our arithmetic right. And then we add 3 on this side and we get 3 plus negative 7, which is negative 4. So here we have x is less than 5, and that's not negative, or x is greater than minus 2. Now we need to think about this logically. This is an or. So it's not really an or. This is where it gets confusing. I forgot about that. So if we think about this, whether it's an or an and depends on if it's a less than or a greater than here. So if we have an inequality that's less than if we have an absolute value inequality where we're saying the distance has to be less than something, we're writing an and. In order for the distance to be less than, both of these have to be true. If we were solving the inequality with a greater than, in other words, the distance has to be more than, then that's when we get the or case. Either one will be true or the other. Here we have an and. So both of these must be true in order for us to get a true solution to this inequality. X must be less than 5 and x must be greater than minus 2. And we usually write the and in this compact form, putting x, the unknown number, in between minus 2 and 5, and using that to indicate our set of solutions. So the set of solutions is all the real numbers that are between negative 2 and 5. Now let's solve this inequality. Again, these are more complicated than we would want to do with the geometric solution for me. You can do this geometrically using substitution. So you can replace 4x with z and think about the distance from z and 1, and then going back and substituting back in. But for this example, let's again do it algebraically. And again, as I pointed out last time, now we have greater than, so this will be an or. So either we have 1 minus 4x is greater than or equal to 10, or 1 minus 4x is less than or equal to negative 10. Why less than or equal to? Because of how it went before with, you really were negating this, and so when we multiply by a negative, we have to flip that. So I skipped that step to make it a little bit faster. So remember, when we skip steps, we open ourselves up to possibility of making a mistake. So be sure you're doing it right. So let's add 1 to both sides. Sorry, see, I'm making a mistake by going too fast. Subtract 1 from both sides on both of these inequalities. Divide by negative 4 in both of them, which makes me flip them both. 9, negative 9 fourths, or x is greater than or equal to negative, and negative is positive 11 fourths. And we could write negative 9 fourths is also the same as minus 2.25, and 11 fourths is the same as 2.75. So we can write it in either form and have a correct answer.